So the first thing we need to do is cut out the gaskets for the assembly, and we have this template with the right sizes. So we just put this under and easily cut out large pieces. And I have separate knives for all the different pieces that I need to cut. So this one is for these Teflon sheets that we use as gaskets. Cut out the electrode area inside. These does not have to be cut super precise, but it makes it easier later on. And as you can see, also from the template here, we cut them the gasket holes slightly larger than what the electrodes are gonna be later on. So we cut in the black line here, whereas the electrodes, in this case the anode, is gonna fill out the blue square here. So next thing we do is to clean them. So they are still pretty dirty. We need to clean them before we can use them. And I'll just show you, if we're just using water, it just peels off due to the high surface tension between Teflon and water. So instead, we're using alcohol, ethanol in this case. And you can see how this much easier goes down. So whenever we clean these, we start out by using ethanol. This will take off all of the dust and also any organics that should be left over on it. And then when we're done, we use water just to remove any residual ethanol that should be there, because even though it sounds a bit weird, the water is actually cleaner than the ethanol. So, and when we're done with this, we put them here on some white tissues and let them dry, covered like this, ready for when we're gonna need them. We need to cut the electrodes. And first we cut the cathode. In the experiment we're gonna do today, it's spotted copper on a gas diffusion layer, so it's a Sigma set 39BB, and these are very fragile, so you have to be careful not to puncture them. It's a carbon cloth with PTFE, so Teflon strings inside, and we've spotted a thin layer of copper on top of it. So, but first we need to cut it out in 1.5 times 1.5 centimeters, and the area here is what is important when we're doing the experiment later on. So I put it down here gently on a piece of dust-free paper, and then I'll try to move it over. I take a knife dedicated for copper, a clean blade on, and then I will try gently to cut it in the right size. And this is not as easy as one could have hoped. can see here, it fits. It's a little bit too large, but then we can cut the edges off here. So we've just cut the cathode, which was a copper cathode, and now we are getting to the anode. And for this, we'll be using iridium dioxide. And the reason I'm cutting it in this direction is because we do not want iridium dioxide on the cathode side, because that is a good catalyst for hydrogen evolution, which we do not want. And if I did so, I would need to clean everything and take on new gloves. Doing it in the opposite way, cutting the cathode first and then the anode, is not as problematic. So that is a good thing to remember. When cutting this one, it comes in these big sheets. What I will do is that I will cut the square out first and then use that one to cut it. And I have here again a knife dedicated for iridium oxide. Of course, we should find somewhere to cut it so I'm not wasting too much. And if you've noticed, the anode is larger than the cathode, and that's because we do not want the anode to be the current limiting side. We just want it there as a counter electrode. Now, the anode is in principle as fragile as the cathode. It's made in almost the same way, but as it's gonna be, you could say, submerged into electrolyte, it's not as critical to keep the hydrophobicity of it. So you can actually puncture it if you want to, moving it around. again, you want to avoid getting any dust on it, so we'll use the same trick with a piece of paper, a dust-free paper here, and then store it here. Now we're gonna cut out the membrane, and for this I now wear new gloves, because now I don't want any metals on either side, because I can of course not keep my hands only on one side of the membrane. So we keep the membrane, it's a Sustanian membrane we're gonna use today. And we keep it in, so it has been prepared in 1 molar KOH, where it has been activated, and then we just store it here in water. So the way I cut it is I use the lid to cut it on, and then originally it came on this plastic sheet, so it was a protective plastic sheet, and I use this as cutting board, you can say. And then we'll get to the membrane itself, and it's lying down here, and it's very fragile, and if it's exposed to air for too long, it will die very quickly. So I put it down here, and then I have a small paper giving me the size. And again, I'll just put it next to it, use the knife, and then I know kind of where to cut. So I will use the line here. And then I'll hurry up, putting down the last piece. And then I put them in a small container, ready for use later on. All with nice clean edges. So